This is another video in the series on the misuse of statistical significance, and the topic this time is bias. But before I get into that, I want to talk about the sources of variance you can have. So, the result won't always be the same, so that's why you want to use statistics to analyze it. And there's a couple of different ways that the results could vary. One is that variance could be due to complicated factors or things that are really tough to calculate, but you expect it to be the same across all people or across all situations. So think of rolling a die. So if you knew the angle you were throwing the die and the force, and you knew where it was going to land and the details about the surface it was landing on, you could probably calculate out what the result would be, but that's very difficult, so it's easier to just use statistics to analyze something involving rolling dice. So that's one way you could use statistics to analyze a problem that is variance. And another type of variance you could have is that you could have the results vary for different people. So I'm going to talk a little bit more about each source. So in the first one, you would want to use a large amount of tests to try and determine the probabilities of each outcome happening. But because it's going to be the same in all different situations, whatever result you can get, you can use all different kinds of situations because you expect to get the same distribution at the end. So there's no risk of bias, and whatever result you get, you could apply to anyone or any situation. And so using statistical methods makes perfect sense in this case, and it's going to apply to anyone. Now, in the second case, though, there's a risk of selection bias because the results vary for different people. So if you choose people in a way that excludes a certain group of people or only includes one group of people, then you might have a problem with selection bias where the results you get don't match everyone else because you only chose one small group of people. So in order to prevent that, you would need to make sure you test a lot of different groups to get a representative sample. So if you don't do that, you run the risk of having biased samples where whatever result you get doesn't match the entire population because you didn't account for a certain group of people. And that could cause you to draw the wrong conclusion from the data you're looking at. And at this point, though, you're probably thinking that this is a pretty well-known problem. You've probably heard about this even if you've taken statistics in high school or something like that. So there's nothing new here. It's not some kind of new problem that people don't know about. And I would say I agree with that. I would say most studies account for this. So it's not really a major problem. But the thing is, there's something that I would call the reverse problem. So it's true that if you have a biased sample, then the result from that isn't going to match the population. That's why that group is biased, because it's not the same as everyone else. But if you turn that sentence around, it's still true. The population result is not going to match a biased group. So even if you have an unbiased result that's accurate for the entire population, it wouldn't make sense to try and apply that result to any specific person who is a part of a biased group because it's not going to match them. That's why their group is biased. So to use an example to talk about this, for me, as a male in my 30s, if I wanted to analyze how something would affect me, I could try and use data from how it affects other people to predict what would happen to me. But there's a lot of different groups I could choose to study. So I could look at everyone in the world, or I could look at everyone in the world who is male, or I could look at everyone in the world who is male and in their 30s, or I could also look at everyone who's male and in their 30s and has similar physical characteristics to me or similar personality to me, all the way down to me specifically. But as you can probably imagine, the closer you get to me specifically, the better the result is going to be. So a lot of times you're not going to be able to test yourself specifically a lot of times. But if you could, that would be the best. But because, again, you can't a lot of times, you could use people who are very much like you and see what happened to them to predict what's going to happen to you if you do something. And that'd be pretty good. But the farther away you get from you specifically, the less likely it is that the result's going to apply to you in the same way. So if you were to do an unbiased study, you would have to use all genders and all ages and all personality types and all physical characteristics. You'd have to include everyone. But if you wanted results for yourself, you don't want that. Like, if I were trying to figure out how good something is for me, I wouldn't want to include the results from like 70-year-old women because it might be different for them, or I wouldn't want to include the results from infants because I'm not an infant. That might be a lot different than what happens to me. So if I want to use the results to make a decision for myself, I don't want those results to include every other group that I'm not a part of. I want the results to be biased towards the group that I'm in. So that's what would make sense. So that's something that you should naturally feel. You don't want unbiased results when you're trying to make a decision for an individual, unless you can show that there is absolutely no difference between every single individual. In that case, it's not a problem. Like, there's no bias at all. So there's no biased groups and you don't have to worry about it. But if it's not the same for everyone, then you don't want other groups of people to be included when you're trying to look at results for yourself. So, to use a bit of a silly example, let's talk about this basketball example that I have. So let's say you're standing somewhere on the court and you want to figure out the force and the angle that you need to throw the ball at to make a shot. And you don't know what it is, so in order to try and guess what it is, what you could do is you could look at pro players and see how hard they throw the ball and what angle they throw the ball at, and try and find the average result, and then take that as your answer. And that doesn't exactly sound like something that makes sense, because so that would be a pretty ridiculous way to make a decision if you did exactly that, because there's very clear differences based on the specific situation. So the very big, obvious one would be where you're standing on the court. So if you're standing at the 3-point line, you wouldn't want to use data from people shooting a layup or shooting from the free throw line, because that's going to be way different than what you want. You don't, so like including in those other results to make your overall result unbiased would very clearly not make sense, because you just want to know what it would take to make a shot from the 3-point line where you're standing and not other spots on the court. And then there's also other details you would have to think about, like the height of the person shooting the ball. So if they're really tall, they probably have to use a different force and a different angle than if they're really short. So that's something else you would want to take into account. But you wouldn't want to have an unbiased result that includes every single location on the court and every single size of person and all of that, because it wouldn't make sense. Like, you're looking at a specific situation, so you would want to use only data matching the specific situation that you're looking at. And any other data that you include is just messing up your results, because like if you're looking at layups, it's not going to be they're not going to be throwing it hard enough to make it from where you're standing. So you wouldn't want that data to be included when analyzing for a single specific situation. So to try and summarize it, I think it really might be a combination of two valid uses, but incorrectly combining them. So if you were to have like all individuals or all situations behave similarly, then it would make perfect sense to take a large sample of different situations or different individuals and kind of get an average result and then apply that to everyone or every situation because they all behave the same. So it makes sense to do that. And then if the only thing you wanted was an unbiased population result, so as an example, you can imagine trying to predict the outcome of an election, then what you might do is you might try and do a study of everyone, and because you can't ask every single person, you only do a sample of people, and you would want an unbiased sample so that you can get an unbiased population result. But in that case, the population result is what you want, and by doing an unbiased sample, you would be getting what you want, so that makes sense too. So both of those uses are valid, are correct, they make sense. But if you tried to combine the two incorrectly and say, well, if you do uh, an unbiased sample of a lot of people, but then apply it to individuals who are part of a biased group, that no longer makes sense. That doesn't apply. That's not correct to do. And if you do that, you're going to be making incorrect assumptions in the same way that you would be making incorrect assumptions if you took a biased group and tried to assume that matched the entire population. Well, it wouldn't, but the entire population would also not match the biased group. So what you need to know is that if the possibility for biased samples exists at all, then you already have this problem. So if you're looking at people and you believe that in any way that some people it might whatever you're looking at might behave differently for different people, or if you think that you should probably include different types of people to make sure you're like covering all types of people, then you already have a problem if the results are something that you would want to apply to an individual or at an individual level. So if it was something that you were going to use to make a recommendation for an individual, or suggest individuals do this because on the average it's better. Well, if you have the risk of biased samples at all, there's going to be this problem, the thing that I'm calling the reverse bias problem, which is that the population result should not be applied to any biased group or any person in a biased group because it's not going to apply. It's not going to match up. Now, in order to know if you might have biased groups at all, you would have to know what the relevant factors are and then group according to those. And it's difficult to do in general. Like, that's also another topic that I'm talking about in a different video series. But if you were able to identify a certain relevant factor, like maybe the results vary based off of the person's height, then you would know what to group by. So you would say, okay, I should group people according to their height because that causes a difference in the result. And then when people are looking at the result, they know which group they're in because of their height, and then they can know what the results are for their biased group. But again, they wouldn't want an unbiased result to look at because that would include all the people that don't match them. They would want to use the people that match them in all of the factors that are relevant. So that's all I have for this bias problem. And I have a couple of other videos where I'll talk about other types of problems.